We are going to simplify this expression. There it is. And before we begin, we have to take note that if you have x, a base raised to an exponent, which is a fraction, okay, the numerator and a denominator, x, a base, or y, whatever your base is, raised to a fractional exponent. There's another way to denote this. There's another way to rewrite this, if you want to put it that way. There's another way to express being raised to a fraction. There's another way to express being raised to a fraction. And this is by introducing the radical symbol or the root symbol. Please, I know we are accustomed of saying square root, but square root is a specific value of the radical. Square meaning 2. Okay, so for example, when you look at this, you are not seeing any value here. There's an invisible 2 there. There's an invisible 2. There is an invisible 2. Anytime you see a radical sign, that's the radical sign and the root sign, there's an invisible 2. Okay? Because there must be a value there. The lowest value is 2. The lowest value there is 2. The value of the root sign is actually equal to the denominator of the fraction, m. So if you do not see a number there, there's an invisible 2. So that's why we normally say square root. Okay? That's why we normally say square root, because of the invisible 2. But the name itself is root or the radical sign. The root sign or the radical sign. So when you say square root sign, you are referring to a specific situation of the root sign. Bear that in mind. And the numerator now, the x now, comes under the radical sign, and the exponent of the x will be the numerator. Okay. So we want to look at it that way. You have 1, 2, 3, 4 symbols here. You have the x, the m, the horizontal line, and the n. These 4 symbols can be rearranged and it expresses the same thing. Take that line and make it a zigzag. So you see how it is there? Increase it, bring it down, and curve it. So I'll just put a little, it's a line for the fraction, you know. I monitor it closely and I say, well, okay, probably that's what the mathematicians did. They just add a little tick, pap, pap, to that line, the dividing line. The base comes under it, and the value of the radical sign will be the denominator, and the exponent will be the numerator. Probably just a simpler way to write. Instead of having the exponent a fraction, it looking a little bit intimidating, it looking a little bit cumbersome, and you have to give it space. Remember, when you're writing, in those days, you did not type in, it was writing their solutions and writing their books with pen. So it will probably be a little bit cumbersome. Remember, there have the lines in the book, and that have to be up, and it probably interfering with the line above. So to fit it in between the lines, I suspect that is why this notation was, design was invented. Okay, so therefore, whenever you see the root sign, this square root, because there is an invisible 2, that is x raised to the power of a fraction, there is an invisible 1. The power of x is 1, and there's an invisible 2. I repeat, the power of x is 1. This is x to the 1. That's why you have a 1 up there, and there's an invisible 2. That's why you have a 2. So the square root of x is the same as x to the half. So you can see how the half go right up. So it might be interfering with the line in the, in your notebook, in your book, and it might be you know, causing it to be a little bit untidy when they writing, they used to be writing, because this has its history, you know, so therefore that is why this notation was invented, so I can fit it nicely between the two lines. That idea just came to me as I'm analyzing that, and I will research it, but I'm sure probably that is why this, you know, symbol, this notation was invented to, you know, so as you can see, bringing down the whole situation, make it fit between the lines when they write in their solution. Because look at how this I have right up there, and it, you know, and look at the line, the upper line, and then the half going and interfere with the information above. Okay, so probably that is why. Now the same thing applying there now, that is the square root of x to the y. So in this bracket, you can have your x to the half. Okay, we have our x to the half up there. So that's square, we paste it back, yes. So that is square root of x times the square root of y. So that would be both the square root of x times the square root of y have a power of a half. So they both, the x and the y, they both have a power of a half. Okay, that's the half there, that's a half that's inside there. And all of this now is being raised to a power of 5. Okay, this is what is happening in the denominator here. X and y have a power of a half, that is square root. There's an invisible 1, there's an invisible 2. And power of a half is being raised again to the power of 5. Okay. So basically, the numerator can remain as is for the time being. Let's copy and paste this there. Now we can apply powers raised by multiplying. So now a half times 5 is 5 over 2. A half times 5 is 5 over 2. Agreed? Half times 5 is 5 over 2. And now, because we are dividing, we can subtract the powers. X raised. You can use your calculator. You don't have to do it manually. A half minus 5 over 2. All right. Talking about a half. Subtract 5 over 2, because the half is in the numerator. That half there is up, so it subtract the 5 over 2. We're going to get a negative number. Negative 2. Okay. And we're going to have 6 subtract 5 over 2. 6 subtract 5 over 2. You have 3.5, or you have 7 over 2. Y raised to the 7 over 2. Now we have to recall another law of indices. Whenever you have a negative exponent, x, for example, raised to the negative n, for example, x raised to the negative n, to be specific, a, where a is any number. If you don't put a, then you are talking about 1. There's an invisible 1. But just to be general, we're going to put a as the exponent, as the coefficient, sorry, of the x. So the a now, if there isn't an a, then you have to put 1. But because we put a, we have to write a comes in the numerator and x comes below with, and the positive, negative power turns to positive. So this and that is expressing the same thing, different notations, symbols, you know. So probably this now, in the reverse now, this was created for that whole idea of fitting between the lines, because if you look at the up and down, okay, so this looks more, you know, cozy between the two lines. So probably this is why this was invented to to avoid the up and down with the fraction, making it easier to write. It's probably easier to write that than write this. You see, when you have a whole set of writing, and you know they write in the math books, and with the pen, you know, the little feather and so forth, and your ink, and you know, in the candlelight writing. So they have to devise easier ways to write all of that over and over. So probably this is a little bit more easier to write than that, and to present the publishing. Okay, so having said that now, so therefore now, the y to the 7 over 2 can remain because the power is positive, but we can rewrite it in this way. Okay, so the 2 come in there. If you don't necessarily have to write the 2, it's not very common to write the 2, but I will still write it. Okay, you can just put square root and you don't have to put the 2. Okay, but just to emphasize, and then the x to the power of, you know, positive 2 will come in the denominator. So here, if it vice versa, if it is down and you bring it up, it will be negative. If it is up and it's negative, you bring it down, it becomes positive. Okay.